Aloha and welcome to Algebra 1 BCPS-TV style. My name is Laura Potter and I'm your host for today's lesson. Before we start doing math, let me tell you a little bit about me. Every day, my fitness goal is to walk 7,000 steps and 8 flights of stairs. This past summer, my family and I traveled to California to visit some national parks. One of the hikes that we did was to the top of Mora Rock in Sequoia National Park. Let's take a look at the trail map and the elevation profile for this hike. Over here on the left, you can see a picture of the trail map, and off to the right, you can see the elevation profile. If I go to the very end of the hike, you can see it's a rather short hike, but look, as I travel from left to right, some of the very steep parts of the hike, especially right here, look, there's a grade of 64%, and what a great big elevation change. When we got to the top, my fitness tracker told me that I had only traveled 600 steps, but I had climbed over 30 flights of stairs. The view at the top was definitely worth it. Let's get started. We're going to warm up our brains with a Think About It task. Today's Think About It asks you to look at the graph and tell someone everything that you can about that graph. Take a few seconds to think about what you notice about the graph. Let's hear from my family as they share their ideas. As you listen, take a look at the graph to help you make sense of what they noticed. Aloha, Victoria.
Aloha.
What do you notice about this graph?
I noticed that it's a basketball court, that the ordered pairs both have zeros in them, and it looks like the basketball is going to go into the hoop.
Thanks.
You're welcome.
Aloha, Finley.
Chesh.
What do you notice about this graph?
I noticed that the graph looks like it's parabolic and is most likely represented by a quadratic function.
Sweet, thanks a lot.
You're welcome.
Hi, Tim.
Hi there.
Can you tell me something that you notice about this graph?
I noticed that it goes through the x-axis at about 9.477.
So can you tell me what that means in the context of this basketball hoop example?
Yeah, that means that since the x-axis is labeled as distance from the shot in feet, that means that the ball must hit the ground at about 9.477 feet away from the shooter.
So what does the zero mean?
The zero tells you that that's when it's hitting the ground.
Nice. Thanks, Tim. The material covered in this first mini lesson is the same as the material in the print packet for Algebra 1 during the week of April 20th. This is the first lesson. On the screen is our first learning objective for today. Today, we will analyze the graph of a quadratic function in order to identify the key features of the graph. In the Think About It task, we looked at the graph of a parabola, which is represented by a quadratic function. I think Finley told us that. Today, we're going to learn vocabulary words that help us further describe the graph of a quadratic function. In our first example, we're going to look at the key features of the graph of f of x. F of x is defined as x squared plus 6x plus 8. All of the key features that we're going to identify are on the right-hand side of your screen, and it will be really helpful to have the vocabulary for this lesson from your print packet. The first key feature that I'm asked to identify is how the graph opens. So when I trace the graph from left to right, I can see that the graph opens up. To me, the graph also looks like a cup, and that's one of the ways that I use to help myself remember that. The next two key features that I'm asked to identify are the intervals of increase and the interval of decrease. There are two very important pieces of information that you have to remember when you're identifying or looking for an interval of increase or decrease. First, you have to remember that you always read the graph from left to right. Second, we are going to identify these intervals by using x values. So we'll begin by looking for the interval of increase. This is the place on the graph where the y values are going up or the y values are increasing. The yellow highlighted section of the graph is the interval of increase. And I can identify that interval in two ways. I can use inequality notation and I can use interval notation. So we'll begin with inequality notation. So values of x that are greater than -3 and values of x that are less than infinity are the x values where my graph is increasing. I can also use interval notation to show that. The interval of decrease are the places on the graph, as I read it from left to right, where the y values are going down. The green highlighted section on my graph are those locations. I can identify those two intervals in two ways. I can use inequality notation and I can use interval notation. So again, I'm going to be using x values to help me do that. So any x value greater than negative infinity and less than -3 are the places on my graph where the y values are going down or the graph is decreasing. And I can also use interval notation to show that as well. I want to point out that I did not include any equal signs in my inequalities, and I specifically want to talk about what's happening at x equals 3. The graph is neither increasing nor decreasing at x equals -3, so I use the curve brackets in my inequality, or I'm sorry, in my interval notation. Remember, when it's equal to, I use a square bracket. There we go. The next key feature that I'm asked to identify is the axis of symmetry. The axis of symmetry is a line that will divide your graph or your picture into two equal reflected halves. So I'm going to draw the line that represents the axis of symmetry for this particular function. And when I identify an axis of symmetry, I'm going to use the equation of a line. The equation of the blue dotted line that I just drew is x is equal to -3. The next key feature that I'm asked to identify is the vertex. The vertex of a parabola or of a quadratic function is the lowest or highest point on the graph. I just drew an ordered pair at that location, which is -3, -1. So the vertex of this parabola or of this quadratic function is -3, -1. I can also categorize my vertex as either a minimum or a maximum. So this point right here is the lowest value on my graph, so it would be a minimum. I can also identify the lowest y value on the graph to give a minimum value, and the minimum value is y is equal to -1, and I got that right here from my ordered pair. The next piece of information that I'm asked to identify are the x-intercepts. Here is the x-axis. And an x-intercept is the place or the location where the graph of a function crosses or touches the x-axis. So I have two places where that happens. That happens at -4, 0 and -2, 0. So I'll label that on my graph, but I'll also label it in my key feature list. The next key feature I'm asked to identify is the y-intercept. So I'm circling the label for the y-axis, so here's the y-axis, and I'm looking for the place where the graph crosses or touches the y-axis. That happens at the location 0, 8. End behavior is how we're going to describe what's happening at the end of the function. So I need to look at what's happening as x goes towards positive infinity and as x goes towards negative infinity. And I'm going to be looking to see what f of x does in both of those cases. So I'm going to trace my function as x gets really, really, really big. It looks like f of x is also going towards positive infinity. As x gets really, really, really small, my function is also going towards positive infinity. The last two key features that I'm asked to identify are domain and range, which should be review key features for you. Remember, the domain represents all of the possible input values or all of the possible x values. In this graph, the domain is all real numbers. And what that means is that I can input any number into my function, and I will get a corresponding output. I can write that using inequality notation, and I use an x here because my domain represents my x values, and I can also use interval notation. My face is in the way. I guess I'll put myself up here for right now. The last key feature that I'm asked to identify is the range. And remember, range represents all of the possible output values or the y values. In this case, my y values go from -1 all the way to positive infinity. So I'm looking at what's happening from the bottommost part of my graph, or the minimum, all the way as far up as I can go. So I'm going to use y values this time. And in this case, y is greater than or equal to -1, and y is less than positive infinity. That's my inequality notation. And I can also write that using interval notation like this. So at this point, we've identified all of the key features of f of x. Today, we learned how to identify the key features of the graph of a quadratic function by analyzing the graph. And now it's your turn to try some problems. Remember, there are completed examples in your print packet that show the identification of key features of quadratic functions. You should also review the definitions on the first page of the lesson. Don't forget, there's an answer key at the end of your print packet. As we move into our next learning objective, let's take a minute to re-energize our brains with a new Think About It task. In this Think About It task, I'm going to ask you to look at the two graphs on the screen and identify something that is alike and something that is different. Take a few seconds to think about what you see that is alike and different between the two graphs on the screen. Now, let's hear from my family to learn about their ideas. As you listen, think about the vocabulary that you learned in our first mini lesson today. Hi, Lily. What's something that you see that is alike about the two graphs?
I see that they are both parabolas.
And what's something that you see that's different?
One opens up and one opens down.
Which one opens up and which one opens down?
The red one opens up and the blue one opens down.
Thanks, Flo. Hi, Spencer.
Hi.
What do you notice that's alike about the two graphs?
They both have a y-intercept of 4 and an x-intercept of 2.
So they both have a y-intercept of 4. What is that as an ordered pair?
0.
0, 4. Okay. And then they both have an x-intercept of what?
2.
Oh, so that's the ordered pair.
2, 0.
Okay. And then what was something that was different about them?
The red one is wider and the blue one's skinnier.
Nice. Thanks, Spencer.
You're welcome.
The material covered in our second mini lesson for today is the same as the material in your print packet for the week of April 20th. This is lesson 2. Our objective for today is to create an input-output table in order to graph a quadratic function written in standard form. We took a look in our Think About It task at 2 different quadratic functions and we compared their key features. In this lesson, we're going to look at the equation of the function and see how we can generate the picture of the graph so that we can then identify the key features. So let's learn about it. Here's our direct instruction for today. One of the ways that we can graph a quadratic function is to create an input-output table and then plot the points. That's really helpful, but it's pretty time-consuming, so we want to also use some of the information from the equation to help us. We're going to begin looking at quadratic functions that are written in what's called standard form. And the standard form of a quadratic function is f of x equals ax squared plus bx plus c. We're lucky because the values of a and c tell us some information about the graph without even having to graph it. The value of a will tell us whether or not the graph opens upward or downward and has either a minimum or a maximum. And the value of c helps us to know what the y-intercept is as an ordered pair, 0, c. So when a is positive, the graph opens upward and it's going to have a minimum. When a is negative, the graph opens downward and it's going to have a maximum. This is a really great place to start, but an input-output table is definitely going to give us more information about what that graph looks like and ultimately to identify the key features of the graph. In this Learn About It example, we're going to graph the function f of x equals x squared plus 4x plus 3. We're going to begin by looking at the structure of the function to tell us some information about what the graph looks like. Then we're going to move into creating an input-output table so that we can plot the ordered pairs and see a full picture of our graph and the key features. So let's begin. The first thing that I'm going to look at is the value of A. In this particular example, A is 1, which is a positive number. When I look at my quadratic function, there's a coefficient of 1 in front of the x squared term. A positive A value means the graph opens up, and that also means that it's going to have a minimum. I'm going to abbreviate minimum MIN. We also know the C value. The C value is 3. This means that the Y-intercept is the ordered pair 0, 3. Now what we're going to do is we're going to create an input-output table so that we can see a picture of the graph more completely. Just knowing whether it opens up or down and the Y-intercept isn't enough. So to create the input-output table, we're going to substitute all of these input values here into our function to get an output. So what that means in this first example is if my input is -4, everywhere where there is an x, I'm going to replace that with a -4, and then I'm going to evaluate that expression. I'm going to use a Desmos scientific calculator, which can be found at www.desmos.com. You can also use a laptop or a computer that should have a calculator installed on it, or you can use a cell phone or a smartphone that has a calculator on it. So I'm going to evaluate -4 squared plus 4 times -4 plus 3. And when I do that, I see that my output is 3. So when my input is -4, my output is 3. And that gives me the ordered pair -4, 3. My next input is -3. So everywhere where there is an x, I'm going to replace that with a -3. I'm going to evaluate that in my scientific calculator. So I have -3 squared plus 4 times -3 plus 3, and I see that my output is 0. The last thing that I'm going to do is write that as an ordered pair. So that means I have -3, 0. So what I'm going to do now is plot these ordered pairs on my coordinate plane. The first ordered pair is -4, 3. So I'm going to start at the origin, go to the left 4 units, and up 3 units, and plot that point. My next ordered pair is -3, 0. So again, I'll start at the origin and count to the left 3 units and up 0 units. So that's right on the x-axis right there. So this gives me some information, but what I want now is a more complete picture. On the screen now is the rest of the input-output table. So you can see all of the rest of the ordered pairs that have been evaluated, and all of those ordered pairs have been graphed on the coordinate plane. So I can see I have a quadratic function that opens up. It has a minimum at -2, -1, so that's right here. There are 2 X-intercepts and a Y-intercept. So now that I've created my graph, I can see all of the important information about the function f of x equals f of x equals x squared plus 4x plus 3. Today, you graph quadratic functions written in standard form by creating an input-output table. And now it's your turn to try some problems. Before you start, make sure you analyze the equation of the function to learn about how the graph opens and what the y-intercept is. Also, when creating your input-output table, evaluate those expressions by using a scientific calculator if you have one. Don't forget, there's an answer key at the end of your print packet. Thank you so much for joining me today. I hope that you feel confident getting started on the try-it problems in your print packet. Practicing what you learned is so important. Take care and stay well. Aloha! The purpose of this video is to show you how to navigate to the print resources for secondary mathematics. First, navigate to www.bcps.org. On the home page, select the Coronavirus COVID-19 Updates and Continuity of Learning Plan link. Then, scroll down to the Student Learning Resources. Scroll to Middle and High School Secondary Resources, And you see once you open up this page, there are folders with all of the secondary content areas. Select Secondary Math, and you're going to be looking at April 6th to 24th. Click on that folder, and that will bring you to all of the PDF files for the print materials.